Yo, what's up guys? Welcome back. Patrick here. I'm moving on to another example dealing with combinations of functions. We got to express each of these functions as f of g in two different ways. So notice in this case we're kind of going backwards from the previous examples. So what we got to do is write two functions, f of x and g of x, where f of g of x is going to end up giving us these functions here. And we actually have to write it two different possibilities. So starting with x squared minus 1 to the power of 4, there's different ways to do this. There's no real way to explain it. You got to just kind of like a puzzle almost figure it out. So you would start with g of x, at least that's what I start with an inner function. So notice that we got this function here, x squared minus 1, within another function, a function to the power of 4. So what we could say here is that g of x would be x squared minus 1, and then f of x would be x to the power of 4. And notice that in this case, f of g of x would end up giving us this, because we had g of x, which is x squared minus 1, so we would have f of x squared minus 1. And we know f of x equals x to the 4, and we can generalize that as f of an expression equals that expression to the power of 4. So we would end up getting x squared minus 1 to the power of 4, which would be the same as this over here. So that is one possibility. You could almost make a bunch of possibilities, maybe an infinite amount of, not even maybe, you can make an infinite amount of possibilities with these. So notice that another possibility can be if we let f of x be x minus 1 to the power of 4, and g of x would be x squared. That would work as well, because f of g of x, in this case, we would plug in this x squared for this x value here. It would be f of an expression equals that expression minus 1 to the power of 4. That expression would be x squared. And we'd end up with x squared minus 1 to the power of 4, which would be the same function right here. And then the reason why I said it could be infinite is because you can play around with this minus 1 in an infinite amount of ways. So another way you can do this is you can say, let's say, let me think here. You can do x squared minus 2 as g of x. And then how do you get from minus 2 to negative 1? You got to add 1. So your f of x would be x plus 1 to the power of 4, like that. Or if this was x squared minus 3, then this would be x plus 2, for example. Now, why is that? So look, we would end up having f of g of x in this case here would be f of x squared minus 3. And notice that f of x in this case is x plus 2 to the power of 4. So that means f of an expression would be that expression plus 2 to the power of 4. So we would take that expression, x squared minus 3. We would add 2 to the power of 4, and that would simplify to x squared minus 1 to the power of 4. That would give us this here. And you could play around with these numbers in an infinite way. You could put like minus 5 here, and this would be plus 4. You could even go positive here, so you could go positive 5, and this would end up being minus 6. Right? So an infinite amount of ways that you can express this f and this g, where f of g of x has to equal that function right there. Okay, now what about part B? We got cos squared of x minus 4. So we got to express this as f of g of x. So what are some possibilities for f of x and g of x? Well, a pretty obvious one is if we have g of x equal x minus 4, and then f of x, the outer function, would be cos squared x. Because if f of x is cos squared x, that means f of an expression would be cos squared of that expression. So if we had f of g of x, we'd have f of x minus 4. We'd be plugging in x minus 4 for that x value. We would end up with this right here. Another way, now cos squared x minus 4, that's the same thing as cos of x minus 4 to the power of 2, right? Both of these are the exact same thing. So another way we can write this is we would make g of x, that inner function here, cos of x minus 4, and then f of x would be x squared. Right? Because if f of x is x squared, that means f of an expression is that expression squared. And so f of g of x would be f of this expression, cos of x minus 4, which would be cos of x minus 4 squared. We would end up with that. So that's another possibility. Another thing you can do is you could play around with this minus 4. So we can do, so let's say the outer function is cos squared x minus 1. So then g of x would have to be x minus 3. Does that make sense? Because we would plug in this expression x minus 3 for this x value. So we'd have cos squared of x minus 3 minus 1, and that would simplify to x minus 4. So that's another possibility. Or if we let this be, let's say, minus 5, this would have to be plus 1. Like that. Because when we plug this in for this x, we'd have x plus 1 minus 5, which is simplified to x minus 4. Right? So an infinite amount of different functions you could have where you could state f of x, g of x, and then f of g of x has to be those given functions.